Hello, everyone. As you can see, I'm a beginner as a YouTuber. I'm going to make a presentation on the laboratory. So let me share the slides. Okay, here I am. So I'm Serge Vaudenay. I'm working in a security and cryptography laboratory. As you know, we have pandemic problem at this time, and we have virus everywhere, and you're likely to see many viruses on those slides. They have infected everything. I'm here saving the world from home. I hope that you're doing the same and that you're safe wherever you are. I'm going to present the laboratory. So the laboratory is quite international. I guess that you have noticed already from my accent that I'm French and Swiss. We have many other nationalities in the lab. So we have Indians, Chinese, Turkish, Korean, Iranian. We have an Australian, and we have three students, which is quite exceptional because there are not so many Swiss students usually. I hope that you will join soon. And this guy won't be here anymore because we didn't invite him. So I'm going to present you some of our research activities. So in this lab, we're working on cryptography. Cryptography is the heart of digital security and privacy. In cryptography, we try to protect data. We try to protect communication. We also try to see if the systems which are supposed to protect are really working. So for this, we have to consider malicious behaviors. So we try to protect against any kind of behavior. And for that, we have to think of the unthinkable. So what is quite exciting in this domain is that we have to model what is the goal of the adversary. So for instance, we don't want an adversary to be able to retrieve some data because we want to protect data, or we don't want the adversary to have access to some services. So we have to model the goal of an adversary. So how to say that an adversary succeeded. We also have to model his capabilities. And so, for instance, he can have access to some server, he can make some requests to some server, he can extract some data sometimes. And then we have to think of any means of malicious behavior. We have to consider anything. So it's quite important domain, and we are quite active. I will show you 5 of our big projects. So the first one is about secure messaging. So I guess that you're all familiar with what secure messaging is. So you mostly use applications such as Signal or WhatsApp. So if you think of two-participant communication, you have a left participant, a right participant. At the beginning, they are initialized with an initial state. The state contains some secrets on both ends, and they can communicate in an asynchronous manner. So they can send messages. They can. So here, this guy is sending a message, but this guy is sending a message at the same time, and so the message cross each other. For some reason, this message takes some time to be delivered. So this participant has some time to send another message. So you can see that we have a quite complicated picture of message exchange. And what is quite challenging is to wonder what happens if there is corruption of a state. Like for instance, so each operation is updating a state. And what's happening if after this sending here, so this participant sent a message, the state which is obtained, which contains some secret, has been exposed because the device was unattended and some adversary were able to get inside and to retrieve the secret from inside. So what can happen if this state is revealed? Then the adversary will be able to intercept the communication here and to simulate the reception. So it will be able to extract the message in clear. So for this message, for that message as well. But for some reason here, this sent message will have updated the state of the participant. And because of this round trip here, so this message here will be safe. So it's some kind of magic in those protocols, is that there is some kind of security healing. So security heals by itself after the corruption of the state. So we are talking about post-compromise security. So we try to make protocols secure this way to prove their security and to compare existing protocols. So that's one research project. Another one is the problem of post-quantum cryptography. So you know that many people are working on quantum computing. And with quantum computers, we can do some operations that we cannot do nowadays with our classical computers. So for instance, we can factor big numbers. And cryptography mostly rely on the hardness of factoring or similar problems. And if you think about it, so if someone tomorrow has a machine which is able to factor big number, then the security of the internet collapse. So it will be a big disaster. So what we are working on now, we are trying to design some cryptographic algorithm which will replace the ones which are being used today, and we want to replace it by some algorithm which will not be under threat with quantum computers. So these algorithms are called post-quantum cryptography. So this is under standardization, and we participate to the standardization program by evaluating the security of some proposals. Another project is something we do with a startup company, Global ID. We make secure protocol to design some infrastructure based on biometric recognition. Here, that's an example of a project where we design some identity document which work like a biometric passport. So we have an identity document with some identity of a person written on it. There can be a barcode which can be scanned, and there is a chip which can communicate and which can do some cryptographic operation. So this document can be read by a reader, which can be useful for a terminal. And the holder of this document can also have his biometric information scanned by a biometric scanner. And then there will be some kind of matching here. We can talk also to a confirmer or database. So what we do here is that we work with finger vein recognition. It means that we illuminate fingers with infrared light, and with a camera, we see the finger pattern inside the finger, and we extract some biometry based on this. Another project is a project which is run by Subhadip Banik. It's a project about analyzing energy efficient cryptographic primitives. So if we try to minimize the energy consumption of some cryptographic algorithm, we will have to make some trade-offs with complexity, security, and this project is about analyzing the trade-offs that we can have, and also analyzing the algorithms which are being proposed. So the goal is to design some algorithms which can be implemented on some very low-cost architecture like embedded systems, for which energy is some important thing. Then we also have another exciting project, which is about sending message to the future. Here, I'm recording this video for you to watch it in the future. So if you watch it, you can think of me in the past. This video is nothing confidential, but imagine what is the problem if I want to send a private message to someone in the future, and I don't know, maybe because of this virus, maybe I won't be alive when people will read the message. So I won't be able to help people to read this message. So that's exactly the problem that we want to solve. So one application is, for instance, to encrypt the will of a person so that it will be accessible a long time after the will has been written. and when the author of this message passed away. So it's quite a new project, and we're working on it. So here you can see some example of some protocols which keep us busy. So I hope that you will be excited also by those projects, that you will come to EPFL. Just don't forget that here in PFL we are quite safe and we are ready. Also, it's not a good time anywhere in the world. In Switzerland, it's still working quite well. So we have some stock of toilet papers, and we are ready for other crises like this. So I hope that you will like the activities that we have, and that you will join us. So I'm waiting for you here, and that's the end of my presentation. So thank you very much, and I hope to see you soon. And please stay safe.